And let's jump into the first part, Azure Resource Manager and ARM templates. Now, what is that? Or what is the Azure Resource Manager? Actually, it's a management service that lives under the covers of Azure, and it's responsible for giving you a consistent management experience when you talk to the Azure platform. You know from your own experience probably that there are several ways you can use to talk to Azure. This can be as simple as using the Azure portal. You could use the Azure CLI, Azure PowerShell modules. You can use ARM templates. You can use lots of third-party tools and extensions such as Terraform, Pulumi, and so on. And the Azure Resource Manager is sitting under the covers and makes sure that your management experience with Azure is absolutely consistent across the board. No matter what tools you use, you will have the same experience all the time. You will have the same permissions. You will have the same policy sets that's actually ensuring compliance of your resources and so on. So this is a very important service, Azure Resource Manager, or in short, ARM or ARM. All right. Now, when we take a quick look at the ARM architecture, I think this is a very important slide so that you can better understand how the Azure Resource Manager works. So when you work with Azure or used to work with Azure in the past, you might have heard of an element in Azure that is named resource providers. So in Azure, we have lots of resource providers. So probably now these days, it's 200 plus resource providers. These are just three examples: Microsoft Storage, Microsoft Compute, Microsoft SQL, and many, many more. And these resource providers are sitting in the Azure platform, and they take care of your resources. They actually give you the opportunity to create specific resource types. Now, if you take a look at the blue resource provider, Microsoft Compute, that means that this resource provider is responsible for managing virtual machines, for instance, or disks, which also somehow belong to virtual machines, or availability sets, or scale sets, and so on. So lots of different resource types that this resource provider is responsible for, and it allows you to create new resources, to change and manage resources, to get out information of the platform about resources, or read information, to delete resources, and also to trigger specific actions. For instance, when it comes to virtual machines, this would mean starting virtual machines, stopping virtual machines, restarting virtual machines, redeploying virtual machines, and so on. So every resource provider manages its own set of resource types. Now, in front of these resource providers, if we want to talk to the Azure platform, we now have this, let's say, this entry door or the front door that gives us access to this whole Azure platform. And this is the Azure Resource Manager that is sitting there, that is offering a set of APIs. So this is the endpoint, management.azure.com, that we can use to actually talk to the Azure Resource Manager. And from there, talk to the different resource providers depending on our actions. So depending on what we actually want to do, right? And this ARM endpoint, or this resource manager API, is used by all the different tools and all the different opportunities that we have to talk to this platform. As I said, it can be the Azure portal, it can be an ARM template, it can be the Azure CLI. Doesn't really matter. Everything talks to this Azure Resource Manager APIs, and that gives us this consistent experience when talking. All right, now ARM stands for Azure Resource Manager. So ARM templates obviously stands for Azure Resource Manager templates, and it's just one way to talk to this API. Now, what is an ARM template? So ARM templates can be used to describe what we actually want to provision in the Azure platform. So it's a so-called declarative approach where we use configuration files to describe the status of our service, how our service looks like. Because if you deploy an application to the Azure platform, it normally consists of one or multiple Azure resources that have or that come with some configurations. And that configuration file that is written in JSON actually has all of that information. So you describe well, I want to have a virtual network resource. This virtual network resource will have this name and it will have this address prefix. I want to have 3 subnets that are using these prefixes. These subnets should have whatever route tables or network security groups and so on. So you describe everything you want to have to make your service work. And then finally, you hand over this declarative configuration file to the Azure Resource Manager. And the Azure Resource Manager will actually read the file and understand what you want, and it will analyze the platform, what is already existing in the platform of what you described, right? So it checks, well, what do you want? What do I already have? And if it's a brand new deployment, if nothing is there, it will deploy everything that's needed specifically to your description in your files. Now, this is the initial provisioning phase when you deploy something brand new, right? So you have nothing and you come from nothing to, let's say, a version 1 of your application. And now that application is sitting in the platform. And this is now where the service maintenance or the lifecycle management actually starts, because this service will need maintenance, which means that the service might need or change a configuration of something. And because we have a declarative approach here, we go back to our initial configuration file and we just change the initial configuration in that file. And then we hand over that same file again to the Azure Resource Manager. And now the same story starts over and over again. It will analyze your description, your configuration description, will compare that to what's already living in the platform, and we'll find out, well, 90% or so of the configuration is already existing, so we don't have to do anything. But now the configuration file contains 1 or 2 more resources or contains some configuration changes, so let's only do this. So all that logic lives in the Azure Resource Manager, and you don't have to worry about how things are done. You just describe what you want, and Azure Resource Manager will take care of the rest. Now, if you have a look at an ARM template, as I mentioned, an ARM template is a JSON file or a JSON file structure, and it consists of several parts. As you can see here, a schema that defines the schema of the JSON file, a content version, which is the version of your file, so it allows you to version your ARM templates, and then 5 main sections, which I only want to touch 2 of them today. One is the resources section, and the resources section obviously contains the resource configurations. So depending on what your application is built on, you need to describe the resource types and the resource configurations that you want. As I mentioned, a virtual network, the subnets, the IP address prefixes, network peering, and so on. This is all described in the resources section. And now, of course, when we build configuration files, we want to follow best principles or best procedures of coding. So that means that we want to make sure we don't have redundant code. We want to make sure that our code is reusable all the time. And this is why ARM templates also have a parameter section that allows you to define parameters that you can then use to submit specific parameter values during deployment time that are then used by the code to, for instance, set a name or set the IP address range of a virtual network, just as some examples. So it gives you this flexibility comparable to a script parameter that you can use here in an ARM template, so to parameterize everything. Now, depending on your exact needs, there's 2 main approaches to work with ARM templates. So you can go with, let's say, the simpler approach, which is a so-called single template approach. So that means you will create one single file, one JSON file here, myservice.json, and this single file contains a description of your full service. So no matter if your service consists of 1 single resource or 20 resources, all that code goes into one single file. And this is fine because it makes the configuration a little bit easier because you don't have to worry about multiple files, how they are linked together. It's just one file, but of course that file will contain lots of code. So you can imagine if you describe 20 services in a single file, this would end up in a file with several hundred lines of code maybe. And the second thing, of course, is if you have one service described in one single file, this normally blocks you a little bit because it will be a very specific type of service. So let's say maybe it's a web application that consists of a web front end, so an app service plan, maybe a SQL database, a SQL server, and some additional services that are needed. And of course, you can parameterize this JSON file, but it will always deploy that same set of resources. So you're kind of locked in when you use a single file approach. If you want to be a little bit more flexible, you could go for the linked template approach. So that's the second example here. And this is where we somehow decompose our configuration file into multiple files. So when we follow this linked templates approach, we normally have two types of JSON files. So on the left-hand side, you can see that my service JSON file, which we normally call the so-called deployment or orchestration file. And on the right-hand side, you have the so-called resource templates. So resource templates are there to just provision one single resource. So as you can see in this example here, for instance, a virtual network or a storage account or a key vault and so on, right? So that means over time, you will build your resource template repository. It will grow over time, and every single JSON file will deploy one single resource. And of course, that JSON file is also parameterized so that these files can be reused over and over again. And now when it comes to the situation where you have to deploy a brand new service, you create a new orchestration or deployment file. So you create a brand new my service JSON file that has the name of your service, for instance, whatever, intranet or something. And then you just define in there what resource templates you need to describe your service. So for instance, you might need a virtual network. So you somehow link that virtual network JSON file to your orchestration file. You might need 5 virtual machines maybe. You might need 2 storage accounts. You might need a key vault and so on. And then you just always reference to your resource templates so that you don't have to rewrite that same code in your orchestration or deployment file. So you reference to these resource templates so that you can benefit from reusing those templates over and over again. So this gives you this advantage. The downside of using a linked template approach is it's a little bit more complex to manage. So from a resource templates perspective, it's easier because these templates are very simple to handle. It's like a template that deploys one single resource. It's not that much code, but the orchestration file can become pretty complex, and also the whole deployment procedure, how you deploy this construct to the Azure platform needs a little bit of more, let's say, more investment compared to a single file deployment, which is pretty simple. Single file deployments also support something that's called a nested deployment. I just mentioned it here. It's not something we normally suggest customers to use. So we either go for like a very normal single file approach or a linked template approach. We normally suggest to use a linked template approach. But nested will become more interesting when we talk about Bicep a little bit later, because Bicep heavily is built on nested templates. All right, so it's up to you what you want to work with. If you start with ARM templates, definitely start with the single template approach, non-nested, until you have some experience. Later, you can continue to invest in nested templates or even linked templates. All right, now if you have your template ready, you're ready to deploy to the platform. And it's also important to understand that there's different types of scope you can use to deploy your template. So as you can see here, there's 4 different scopes you can use to deploy something to. For instance, you can have a resource group deployment, which means you deploy something into a resource group, in an existing resource group. Or you could deploy something at the subscription level, which means you deploy something at that subscription level. Same is true for management group and for the tenant level. So that's actually our resources hierarchy. And now the question is, well, what do I deploy to what scope? It's actually very simple. Whenever you deploy a resource, So whenever you describe a resource in your ARM template, this will always go to a resource group because you always have to deploy resources to a resource group. So now what does that mean? What else can you deploy at higher levels in your hierarchy? For instance, at the subscription level, you could deploy new and empty resource groups. So before you can have a resource group deployment to a resource group, you obviously need an empty resource group first. And this could be deployed at the subscription level. Or at the higher levels, you could also deploy, for instance, policy definitions, policy assignments, role assignments, and so on. But we will not touch that today. So today we will only focus on resource group deployments. All right. So now you know where you want to deploy your ARM template. You have written your ARM template, and now the question is, well, how do we actually hand over this code to the Azure platform? And for that, you again have several options. The simplest form, but not normally recommended, is to use the portal. So you can use the Azure portal and bring your code, your ARM template to the Azure portal and deploy it from there. But as we are infra as code guys, we normally don't do that. So we hand over the code with code. So with some scripts or something. And so that means that you could use PowerShell, you could use the Azure CLI to hand over the code to the Azure Resource Manager API. Or of course, if you go a little bit further, you would use stuff such as release pipelines that give you this ability to have structured releases of your code. I know this is something that will be covered, I think, in the next or in the user group meeting afterwards, but definitely in some of the later meetings. All right, so let's jump into the demo to quickly see how this looks like. All right, so I will pull, if I can find it, I will pull my Visual Studio Code here. And I'm already authenticated against my Azure subscription, so I will not do that. But I want to show you two simple examples of ARM templates. So demo 1 and demo 2. So let's quickly open demo 1. And you can see that this is the simplest form maybe of an ARM template, at least an ARM template that deploys something. So as you can see, all the sections are empty. I have no parameters. I have no variables. I have no functions. I have no outputs. But I have one single resource described here. And as you can see, because I talk to the Azure Resource Manager, I obviously need to instruct Azure Resource Manager what resource provider I want to talk to. So this is the resource provider, Microsoft.storage, and what resource type I'm interested in. In this case, it's a storage account, right? Now, also important is this. I need to instruct the Azure Resource Manager what resource provider API I want to talk to. Because every resource provider, again, offers multiple versions of APIs. And it's up to me to select what API version I want to talk to. So if you start from scratch and deploy a new ARM template, you would normally always go for the latest API version. But because Microsoft can change the APIs and the underlying logic, it is in theory possible that a new version might break your code. But because we have this flexibility to select what API version we want to talk to, this means even when Microsoft releases a new API version, this doesn't affect our code because we still talk to the old version, and we can then easily test our code against the new version. If everything works as expected, we just change the code version, the API version. Sorry. If the code will break, I need to inspect the code and see what I need to change to make it work against that new API version again. So for now, I just picked this version. This is fine. And then if you ever deploy the storage account on the Azure portal, you know that you now need to specify some values. One is the location where the storage account goes to. This is West Europe. We need to give the storage account a proper name that is unique on the globe. So that should be unique, hopefully. And then I need two more configurations. So one is the SKU of the storage account, which is actually the replication option, which in this case I use standard LRS, and then the kind of the storage account, which is storage V2, which is like the normal storage account you would use normally. So everything is hard-coded here. That's not a very good example, but it's a good starting example to actually show you how this works. So now, before I can hand over this code, I need to make sure that I have a resource group. Now, in my environment here, I have 2 resource groups, but I will quickly create a new one. So let me create a new one with the Azure CLI, Azure Group Create. I'll give it a location, which is West Europe, and some name, ARM test. It takes 2 seconds, and now the resource group is there, and I'm ready to deploy my code. Now, as I said, I can hand over this ARM template in various ways. I will again use the Azure CLI. That's my favorite way to talk to the Azure platform outside of ARM templates. So I will now create a new deployment using AZ deployment. And now I need to instruct, well, is this a resource group deployment or a subscription deployment or a tenant level deployment? In my case, it's a resource group deployment. So I want to deploy that to my new resource group. And because it's a new deployment, I will, create a new one. So AZ deployment, inside a resource group, I want to create a new deployment. And now, of course, I first need to define, well, what resource group this should go to. That's the one I just created, so ARM test. And then secondly, I need to define my code. And by using -f, this allows me to just submit my file, which is demo1 JSON, that file that you just see here. So I submit that content. Now this in the backend somehow translates into a REST API call that I don't have to worry too much about for now. The Azure CLI is taking care of this. And by going back now to the Azure portal, I should now see that my resource group has been created. If I go in there, I assume the storage account is not yet visible. So it's still empty, but I can now check the deployments, because if I go to the deployment section of my resource groups, this shows me all the ARM template-based deployments. And I can see that this deployment now already succeeded. I could go into the details to better understand, well, what actually deployed a minute ago. And as you can see, well, I get some overview, not of interest. I can see the templates that has been used, and this should be exactly the template I showed you. So everything hard-coded. I could see the input parameters and the output parameters, and we know both of them have not been used because everything was hard-coded. So obviously everything worked. And if I go back to ARM template now, I should now see that storage account in there. So everything works fine. Storage account is there, exactly how I configured it. Now, of course, I could add much more configuration to my file. This is just the minimum that's needed. I could, of course, well, add containers, add container configuration, configure cores, or whatever is needed, and whatever I understand here by consulting the ARM template reference documentation. But for now, we just leave it like that. Now, the cool thing, as I mentioned, I mean, this is a simple example, but it is sufficient to show what happens now if I want to update this resource, because it's now living in the platform. So let me simulate a productive change. So if this is in production now, and I now want to change some configuration, and first, of course, it's important to understand not all things can be changed. Not all properties can be changed. So you need to understand what properties of a resource can be changed while it's already deployed. And that's just, well, the simplest one I'm using here is I will just add a tag section. So I maybe missed to add tags, so I don't know who the owner of this storage account is. I have no cost center configured. And now it's important. I just go back to my initial configuration file, and I will add a tag section now. And for now, I'll just add one owner. So this is the only tag I want to add now, owner. I save the file. And now you can imagine if this is a production storage account, I mean, it's kind of critical to just maintain that storage account with new code. So because before I release this code to my production platform, I want to make sure that this is rock solid, that it's tested, that I know what exactly will change. Now this is easy. It's just one single resource, and it's pretty obvious what would change. But if you have like a very complex service that might consist of 10 or 20 or 30 different resources, this is a different thing because you now touch the production environment. And of course, this first goes to a dev environment. It then goes to a staging environment before it hits production. But still, even if you hit the production environment, you want to know what exactly would change if I would release this code to the platform. So now what I could do, I could now just repeat the same code again, saying, well, please deploy this JSON file to my ARM test resource group. And this would work. It would do something. Now, obviously, we know it would just add the tag. But if you go to a production environment, you could use something as simple as the -c parameter, which is the what if parameter, which says, well, before I deploy this, I want to first tell you what would change now. And this actually compares your code to the real world platform and will give you a good overview of what would change if you would release this code to your platform. Now we know this should just add the owner tag, but this definitely proves it. So it tells me, well, this is what I will touch. So the ARM test resource group, everything that's purple will be changed. So my storage account will be changed. And what will change? It will just add a new tag section, and it will add the owner tag with the value Marcel. So one resource will be modified. Do you want to proceed? Yes or no? If this is exactly what we expect, we proceed. And now it will just reapply that whole template. And the only thing it will actually do is to really add this, this owner tag. So this will take, again, 15 seconds or so. So why this happens, I will quickly want to show you some other things. Let me now manually add another resource to this resource group. So I'm still in ARM test, and I will deploy another resource. So one that is pretty quick. So let's pick a network security group, for instance, because that's very easy to configure. So I will again deploy this to my ARM test, and I'll just name it NSG test in, well, East US is fine. I create this. Validation runs. So this looks good. Now let's create that network security group. While it's provisioning, I quickly will check my storage account. So I'll go to ARM test. My storage account is sitting there. If I go to the storage account now, I will actually see that my tag is now set here. So it's now configured. Everything else is untouched because it recognized, well, the only thing I actually need to change is the tags property, and it just added this. So it didn't touch the containers. It would not have touched the content of my storage account if anything would be there. It just changed the tags section. So this is what gives you very good control and allows you to maintain your services over time, which is much easier and much, let's say, much more controllable compared to an imperative approach where you do that with classic PowerShell scripts, for instance. All right. So our NSG should have been deployed now. So let's see. Yeah, it's sitting in there. And now if I go back to my code, I just want to quickly show you some other thing. I will remove that -c for now. This is not of interest. But if I release my code now again, what this would do, it would check my configuration and it would again deploy it to that resource group ARM test, finding out that nothing needs to be changed. Now, what's important here is that it will ignore that network security group that I created manually, because that network security group is not part of my code. It will only touch whatever is described in this code. Why is that? Because by default, a so-called incremental approach or incremental deployment is used. So it will only touch what is part of my code here. But if I use this mode here, I could change that incremental mode and switch to complete mode. Now, complete mode means I deploy something to this resource group, and I want this resource group exactly to look like my code configuration. And now because that network security group is not part of my code, this will actually be cleaned up. So it will delete that network security group because I'm using now the complete mode and it is not described in my code. And so it will actually make this whole resource group look the same as I described it in my code. So within some seconds, this network security group will be gone. So it's deleted now. So take care when using complete modes. Definitely make sure that you use that what if you use complete mode to understand and first understand, well, that would now actually delete some resources. Is that really something I want? And if so, you proceed. So it's up to you if you want to use the incremental mode or the complete mode. Actually, both is offered. All right, now let's switch to a little bit of a more complex example. It's still very simple, but demo 2 does exactly the same thing. So let me quickly go to the resources section. So you can see the resources section is exactly the same. It's the same code. The only difference here is that you can see the values, the location, the name, the SKU, and the kind value, they are not hard-coded anymore. They are now parameterized. And this allows me to reuse this JSON file over and over again. So whenever I need a storage account, I can pull this JSON file, deploy it, and then submit the values for location, name, SKU, and kind. So it's now not hard-coded anymore. But this means I'm pulling these values from the parameter section, and that also means that I, of course, need to configure the parameter section first. So I did that, and in here you can see that I now have these 4 parameters: location, name, SKU, and kind. And if I, for instance, start with a location, you can see that every parameter has a type. So there are several types of parameters. String, for instance, that's what I'm using here. It could be an integer, it could be a bool value, it could be a full object, so a more complex configuration. It could also be a secure string that protects the value that you're submitting so that you cannot see it in the portal later. But this is just a simple string. And what you can also see is that I defined a default value, which means if I do not submit a location value, it will just use West Europe. If I submit a location value, it will use the submitted value over that default value. So the same is true for name. This is just a string, so there's no more additional configurations here. The SKU is interesting because the SKU is also a string, but you remember when I hard-coded this value, I used something such as standard underscore LRS. And this is a value that the Azure Resource Manager or the resource provider understands. So here I cannot use just something like whatever, blah, blah, blah. This would fail because the resource provider would not understand this value. So I need to submit values that are understandable. These are, of course, documented in the docs. And to make sure that I don't run into any issues here, I defined allowed values. So these are values that obviously work, and it's also at the same time the only values that I want to be used when I use this template. So standard LRS, standard GRS. I could also, in addition to that, define a default value, but that's not done here. And then for kind, same thing. It's a string and just a default value. All right, so now let's see what happens if I use this. I remove the complete mode and I use the exact same thing, but this time I deploy demo 2 into the same resource group. All right, now if I start this, it obviously knows, well, you need to submit 4 parameter values, one for location, but location has a default value set. So it recognizes and respects that. It will use West Europe as the default value. But now for the name, I need to submit the value. Well, this is the value of my storage account. Next is the SKU. So what SKU do I want to use? And because I defined the allowed values, I can now just select 1 or 2. and it would then use that value and then continue until I submitted all the different values, and then it will start deployment. But I will terminate that here. Oops. Because I want to show you a second thing that is much more convenient by using a parameters file. So that's the other option, because you don't want to end up with entering some values on the command line, of course. It's much more convenient if you store your parameter values in a params file, which is also a JSON file. And you can see here, I submitted, or I configured a location value in here, which is West Europe. I defined the name here, I defined the SKU, and I defined the kind. All right. And now if I want to deploy this again, I use the exact same command. I want to deploy demo2.json, but this time I also want to submit a parameters file, which is demo2.params.json. Now it reads the values from there and creates a deployment based on those two files. Let's see in a second, this should start. And while it's running, this also gives you like very good flexibility, because, for instance, imagine you could have multiple params files. So for instance, if I rename this and just call it demo2 params production, and then maybe a second file that is named params2.def or something, you can have different parameter files with different values. So this would then have like another name, and maybe in def I would just use LRS and over GRS and so on. And then I can use the different parameter files with the same actually code that releases my application, but I'm very flexible with submitting the different parameter values now. So this is deploying. Let me go back to the portal. We should now see it in the deployment sections. Demo 2, there it is. It's already successful, but let me now dive into demo 2. Let me check the template. So I can now see my template. It's the parameterized version of it. And because it's parameterized and we know we submitted some input parameters, I should also see those in the input section now. So these are the values I submitted that have then been used in the code. If I would have defined some outputs, I would also see the output parameters, but I didn't. All right. So these are like some basic principles you need to understand when working with ARM templates, and I think a good basis that you can use to build from there and to go then a step further into more advanced scenarios. All right, now coming back to these JSON files. I know that lots of people, lots of our customers also, they struggle a little bit with developing those ARM templates because, yeah, I mean, people say ARM templates are human readable. They are kind of, but if you have a very complex ARM template, and this is still a very simple example, they become pretty hard to read, actually. And this is where this thing comes into play. And I want to quickly talk a little bit about Bicep Lang now. That gives you another option to actually develop your ARM templates. So what is Bicep or Bicep Lang? Well, we all know this. ARM templates are not so easy to develop. They're not so easy to read. You know, there's strange formats with parentheses, brackets, curly braces, commas, lots of lines of code. It can be pretty hard, especially if you only use this from time to time. If you use this a lot, you get used to it, of course. But if you only use it from time to time, it's actually pretty hard. And this is why Bicep was actually introduced. So it's a new domain-specific language specifically to abstract the complexity of ARM templates for you. That's what it is. It's there to make your ARM templates authoring experience much easier so that you don't have to worry about ARM templates at all. That sounds like a dream to lots of people now. And this is how it works. So this is the actual procedure. So until now, we started here by developing our ARM templates we handed them over to the Azure Resource Manager, and this guy deployed some resources for us or managed the resources for us. But now we have a step before this to actually create our ARM templates by using Bicep. So Bicep is that language that allows us to write our configurations as code, but not as ARM templates. It's in Bicep lang. And we then compile this code into ARM templates. So all the hard work is done by Bicep for us. Now, this is pretty cool. Now, before you start your Bicep journey, this is the tooling that you need to understand or that you need to have installed. So first, if you use Visual Studio Code as your IDE, it's very helpful if you install the Bicep extension. This gives you like this good development experience for Bicep files, and it also validates your Bicep files. And then for now, you still need the Bicep CLI to then compile your Bicep configurations to an ARM template. All right. Already enough talking. Let's jump into action. All right, so I have demo 2 here, and I have several demos for showing you Bicep. So let me quickly change the directory here. There. All right. Let's start simple. So I brought some Bicep files with me. I don't want to author from scratch, even if it would be that simple to do so. But let's have a look at the first Bicep file. Now you can see here I installed this extension already, and you can see it when I open this file. Down here, you can see that it recognizes this .bicep extension, and it actually started that Bicep language server in the backend that gives us this smooth authoring experience. Now look at that. This would deploy a network security group for us. And it's as simple as that. You define, well, I want to describe a resource. So that's the resource keyword that instructs Bicep to deploy some resource. Then every resource you configure needs a symbolic name. That's a Bicep internal name, if you will. So it's not something that you will see in the Azure portal afterwards. This is an internal name. And then you define, well, okay, what type of resource do I want to provision? And now you already understand this because we instruct Bicep that we want to talk to the Microsoft network provider, want to deploy a resource type of type network security group. And this is then, again, the API version we want to talk to. All right. And then we define the properties that we want to submit values for, which is the location and then the name. That's it. So no more freaky, scary brackets and so on. It's as easy as that. If you ever worked with Terraform, maybe this might look very familiar. So it's very close to what Terraform actually is. All right, so this is it. Again, if I use Visual Studio Code with that Bicep extension installed, as you can see, it also gives me like that IntelliSense-like kind of authoring experience, saying, well, you could also add tags. Well, why not? Let's do that. Okay, that's obviously an object, and now I can start adding my tags here. But I will not do that for now. We just keep it very simple. All right. Now what I need to do is, before I can actually use this, I need to compile this into an ARM template. And for that, I need the Bicep CLI. So I installed that already, Bicep CLI. This tells me, well, you need to submit some argument, which in this case is very simple, Bicep build, and then I submit the path to my Bicep file. And this creates the ARM template for me. And now you can see here that the ARM template is now there. If I open this, boom, there we are. This is being created for us. So it's a complexity abstraction that helps us to create ARM templates much faster. Now you can imagine this is a simple example, and you might say, well, this is still very easy to deploy and to develop. But if you have a complex thing, a complex configuration, this is quite a bit different. I will show you afterwards. So let's dive into the second Bicep example. Now, of course, in Bicep, you can also use parameters. So you can see same example, same network security group, but this time I parameterized those values. And that means that I need to add, in this case, add the location and the name to the parameter section, which uses the params keyword, which is for the name just a string and nothing else. And for the location, I again defined, well, the default value should be this, and the allowed values should be Switzerland North and West Europe. No big deal if I compile this. If we have a look at that JSON file, same thing we've just seen in the ARM templates before. This adds the location parameter, it adds the allowed values, and it adds the default value for me. For the name, it's just a simple plain string. Now that's 26 lines of code. The Bicep file has 13 lines. So it's 50% less code. And I even have a blank line here. That's a little bit less. But still, not so complex. Let's take a look at the third example. I mean, this is the same. I just added a little bit more of a configuration of that network security group. This would add a security rule, so we'll skip that for now. And this is a little bit more complex. So this example deploys two resources in the same Bicep file. So as you can see, I have a virtual network here. And I also have a network security group. Because if you ever work with virtual networks, you know that you can have virtual networks. A virtual network can have subnets, and the subnet can have an attached network security group to control in and outgoing traffic to the servers that live in the subnet. So what I did here is I first created that network security group, simplest form, so I didn't add any rules here, just to keep it simple. And as you can see, the location and the NSG name, they are parameterized up here. You see the location has no default value, but the NSG name has a default value. So you can even set the default values in the Bicep file for a specific parameter if you want. And then the same is true for the virtual network here. Again, location, we'll use the location parameter. The name will be parameter, the NE1 name. Then I will submit the suffix of, or in this case, it's actually 2 address ranges I will use for that virtual network. I will then create, this is again, it's parameterized, but it's hard-coded to one single subnet. I will create one subnet with, again, an address range, which is that one. And then I will also automatically assign that network security group I created a step earlier. So I want to attach this automatically to my new subnet. So let's see what happens now. Let me, what's the number? It's 21, Bicep 21. Let's compile that. Now let's see, this was 35 lines of code. And now I have already 66. Yeah, it's still approx 50%. But you can now see that it starts with this fancy code. This is what makes the ARM template a little bit less readable, right? Because of course now it needs to somehow configure multiple resources. It needs to configure dependencies between these resources, because now Bicep and ARM needs to make sure that the NSG is deployed first before the virtual network is deployed. Otherwise it would fail, right? So that means that it will also automatically add dependencies. I didn't have to worry about this. So Bicep supports explicit dependencies because, I'm sorry, implicit dependencies, because it understood, well, the network security group needs to be there first because the virtual network needs the ID to reference to that network security group to actually create a subnet. So I didn't have to worry about this. Again, Bicep or the compilation process takes care of this for me. And all the rest is just plain ARM code. So this would deploy my network, the network security group, and it will link it as well. So let's just for the reference, just quickly deploy this. Because because I'm a lazy guy, I'm always reusing my code here. So deploy demo 21 location with West Europe. I don't have a params file now, and all the rest should be in the code. So that deploys, and we'll see later if this worked. Now you remember that I mentioned in the beginning that code should be reusable, and one thing we can do with ARM templates is using the linked template approach, which is a little bit complex. And Bicep also makes this process a little bit easier by supporting a concept called modules. Now in here, just forget about that for now. In here, you can see that I have 5 Biceps files. So one is obviously a file that, well, translates into an ARM template that creates a storage account. Again, very easy stuff. A virtual network. This deploys a subnet, and so on. So every single Bicep file is responsible for provisioning one single resource. And now when I want to create a full service that consists of multiple resources, I can use these Bicep files as so-called modules. So let's go into the main Bicep file here. And in there you can see that I now use these 4 Bicep files as modules, saying, okay, for deploying my full service, I obviously need one storage account. And for that, I want to use this storage account Bicep module. Now, if you quickly go in there, you can see that it deploys the storage account exactly the same way I showed you before in the ARM template. And for that, I need to submit 4 values: location, name, kind, and SKU. And this is reflected here as well. So if I open this module, I give this again a name, and then I need to submit the 4 parameter values to deploy the storage account. Switzerland North, the name is storage. Well, obviously not such a good name. Something like that. Let's keep it short. Then I have a network security group, same thing. I want to attach to this module or use this module. This needs 2 input parameters. The same is then true for the virtual network 1, the virtual network 2, and then subnet 1 and subnet 2. So at the very end, I should have 2 virtual networks, 2 subnets in total, a network security group, and the storage account. So now let's remove this again. Let's start with the initial file. Oops, not good. Let's not save that. All right. So I quickly go to my second folder. There we are. And now I do the same thing. I just compile that main file, Bicep Build main. I will not touch the other Bicep files. I will just compile the main Bicep file. Done. Now you can see I have this main JSON. Now quickly coming back to this, just to show you the difference. This was 60 lines of code. Now having a look at this file now, at the ARM template, this is a lot larger. So this is 360 lines of code. And as you can see now, this is not so cool to read. This uses a so-called nested template now. So it will create one main deployment template, and in there it will contain nested code. But I don't have to worry about it too much because for me, I will just deploy my file now. So let's do that. This is demo, not demo, sorry. This is now main.json. And this will now deploy as well. So to finish this off, I'm a little bit over time already. Let's go to the portal to see the result. Where is it? There we go. So first off, we should already see the deployment from before, that NSG and the network from demo 21. So that is obviously there. Let's quickly check. This is my network. I should see one subnet, and that subnet should contain a security group that is attached to it. I can see it there already. So that obviously worked. And now we're deploying that more complex nested template. So let's go into deployments. Now you can also see here that this is now shown a little bit differently because it's a nested template. This is the main template. And from there it deploys nested resources. So all of these are like kind of individual deployments. And I can deep dive into all of them now. You can see the details of the full orchestration file, or I can go also into the details of every single resource that has been deployed here with, again, all the input parameters and so on. And this was successful, so the full deployment went well, obviously. So let's see if that is true. Should now see a bunch of resources. There we go, 2 networks. I have, well, that storage account here. I have this network security group, and in here I should also have the subnets. Let's see. Yeah, 2 subnets, and both are using the same network security group. So less code, better readability, and quicker results by using Bicep. All right, so I hope that was impressive. So to quickly sum up these 2 parts of that session, what are the key takeaways? I summed this up very simply. Yeah, Azure is cool. ARM templates are very cool. Bicep is even cooler because it makes you faster. And I really suggest to learn all of these. Start with Bicep. Don't worry too much about the ARM templates. If you never worked with those before, start with Bicep, start compiling stuff, and then maybe also have a look at the ARM templates to see how they have been constructed by using the Bicep build or compile process. It's always good to understand what happens at the back end, but at some point this will not be needed anymore. For now, just as a warning, Bicep is in version 0.2. 0.3 will be released very soon. I don't think it's been released yet. It will be released in December or in January, I guess. And it will add additional functionality. For now, it's still a little bit limited, but well, it's around. It's there to play. Don't use it yet in production, of course, but it's good to start your Bicep or ARM template journey. All right, that's it. If you're interested in infra as code, you can find me online on my blog. You can find me on Twitter, or also check out my YouTube channel. It's not much stuff there, but recently I published Infrastructure as Code series together with my good friend Martin from Norway, and we published, I think, 5 or 6 live streams, everything around ARM templates. There you can also learn about like more complex approaches, more complex templates. You'll also see a quick Bicep intro and some other cool stuff such as deployment scripts and so on. All right, that's it. That's it from my side. 6 minutes over time. I hope this is still okay, Manu. It's 10%. I think that's acceptable. And with that, I will be open for questions if there's anything around.